And now we come to the point where we have to discuss blending. How to soften the joints and connections between wings and fuselages and wings and wingtips, and otherwise hard, discrete edges that have to exist on a plane, but sometimes you want for aerodynamic, aesthetic, or other reasons to really soften that transition. So, the first thing that should go, without saying, or maybe it does need a little bit of saying, is that it's a choice. Certainly the plane we're showing here, what we've progressed to through a series of videos, is fine. I mean, that is a plane shape that probably with some actual math put into it, and probably a different airfoil for the wing, would fly well. I mean, with some adjustment, you can manipulate this into something that works wonderfully. There's no absolute need to put a blend on this wing. So what I'm going to cover in this video is optional. Not optional as far as homework goes, perhaps, but optional as far as design requirements go. You don't have to always blend in the wing and the fuselage. In fact, in many cases, if you're approaching something for cost, if you're wanting to make something simple or fast, get something out the door that just works, a blend would be a bad choice. If you want to keep the design as simple as possible, then just do everything with square sides, forget the lofting, just focus on simple, 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 easy. Fold up foam board and call it good and done. But anyway, if you are wanting to progress to something a bit more sleek, a bit more aerodynamic, a bit more sophisticated, we'll certainly help you develop the skills right now to do that. As a first step, I'm going to go back in time a little bit to really just look at half the airplane again, because most of our work should be done on the half shell. Not to quote the Ninja Turtles too much, but there we go. I suppose we could conduct all of it right there. Just leave the model rolled back, and then we can adjust things into the future. So let's do it from here. I don't need to knit. In fact, I'll leave the tail. In fact, yeah, we don't need to do any of that. So the very first thing I like to do when doing some sort of blend is to nuke the wing. We're actually going to hide that back, and I'm sure some of these practices I'll show may not be exact best practices, but they certainly work, and I've used them for quite a number of aircraft. So let's very cleanly make a line that's going to cut this wing open. We're going to intentionally create a gap between the wing and the fuselage. So that gap going vertical, so let's do an extrusion, mid-plane, maybe 12 inches tall. Okay, that surface is going to be what slices the wing. Now it's on the side, on the right plane, let's make a sketch that... Choices. Let's go to the other side because that'll be an easier intersection to see. Yeah, way easier. We're going to approximate where we want this blend to come in. And again, I'm going to hold down Control. Nope, that wasn't Control. So we don't get that snapping. That's kind of annoying. I don't want that. You want to line it up roughly with the trailing edge because you imagine that makes some sort of a sharp transition point. Let's just wrap it right around the front. And unlike my other, well, no, I will keep with the convention of separating top and bottom. In fact, I don't even think I want that control point, so let's see if I can just eliminate that. That point? Yes, okay, good. And then I can achieve everything else with handle manipulation. Yeah, maybe. Okay. Same thing here on the bottom. Pretty simple. Let's just do that with handles. Obviously that shape by itself is not great, but we can then bring these up. And I guess, yeah, I'll go ahead and constrain them to be vertical. I'll probably have to move that point to a different location just to be kind of in front of the other vertical constraints I've made. Obviously that requires a little bit of modification here, but that should work, right? I mean, should-ish. If not, we can always come back and change it. We'll probably have to zoom in a bit more because I need to get a little bit more tension on the bottom side. I think that'll be fine. That's a good starting point. And then now what we do is actually go through, and using that sketch, we should be able to trim. So the surface standard trimming tool will actually be the sketch. Keep sections that. Okay, that worked. Which means we actually, I don't think, need this surface at all. Just delete that. The sketch stayed. Hopefully do trim surface, standard trim. Trimming tool will be the sketch we made. Keep sections, the outer section. Okay, cool, good. So now we have this big gap that's open, and we're going to actually fill that in with a blend. Conveniently, if we look, it should, yep, there it highlights the top and the bottom surface, which is there again? Nope, it looks about right, because there's also a top and a bottom edge for the wing. And if everything works out wonderfully, you can sometimes just get it to loft straight between the two. In fact, with a linear loft, it looks great. It's not going to give you the exact shape you want, but hey, it's a start. So it's just a linear interpolation between the two. What? Oh, right. It works nicely. In fact, if you want to guide things together, you can do that. Connecting the edges like so. And then so that should be a blend. And I mean, okay, technically that if that's what you want, fine, great, good. But hopefully not. Hopefully you're aiming for better. Let's manipulate this top loft, and if we're the most lucky, which I say luck because it all depends on the exact airfoil you've chosen, the shape you have, the fuselage you're blending to. Some shapes are certainly more complicated than others to achieve with these methods. So we've done a tangent switch, so it's trying to achieve tangency on both sides, which it looks to have reasonable success with. This tip back here is going to be the hardest piece, and we'll see how successful we are with that soon. But overall on the front it looks healthy. Let's just go ahead and take take what we get easily and see how the bottom does. Oh, yep, it broke. That's good. So right click, edit. Let's make things a bit easier and let it deviate from those edges a bit to begin with. Put our constraints in. Tangency. Handles at 1.0 tension. And yeah, so you see it's doing okay until it gets to this very back where it wants to overlap naturally. We're not forcing it to stay on the same line. We could try, but that's what killed it earlier. And gosh, I can't really tell what it's wanting to do. Just click OK and see what it did. Yeah, it doesn't solve whenever we click that edge. So obviously it's having a mathematical challenging time in fulfilling all the surface edge requirements with a lofted surface between those edges. With this circumstance, in fact, maybe we can get it to adhere to the front. Whoops, come back. It works okay. So anyway, that's what a loft can produce for you, and it's not terrible. I mean, I've seen much worse first attempts. In fact, the fuselage blend there looks quite nice. You see in the back it's actually overlapping two surfaces, but that's pretty easy. In fact, this is almost an ideal case because then all you have to do is just say trim, mutual, these two surfaces, keep selections, that one and that one, trimming off only the excess, and then there you go. So it's a bit odd. I mean, you have to be just accepting and passive about that little cusp that's got cut into the wing a little bit, but that would be a nice, very pretty trim between the two surfaces. If you didn't like the exact shape, then well, you could go back here and modify where this maybe I don't want to blend it out as far into the wings. You can just take the whole cut, move it in, and there's a pretty good chance I just destroyed the entire stability of this operation. We'll see. Recalculates everything, and hey, it looks still pretty good. Man, if only you knew the number of hours I've developed to be able to do this in more or less the first shot. So don't feel bad if you're frustrated and fighting this for quite some time, because this is an advanced SolidWorks operation. I mean, it took me a lot of time before I could actually accomplish this. So I'm a little bit proud that it went so easily this time. Now, let's stop and think about how you actually build this. This is pretty much requires a molded construction, right? That's a sophisticated curve, a sophisticated blend. Unless you're really just chasing that last bit of boundary layer stability, minimizing boundary layer interactions, or have a very compelling reason to be pretty. This is probably not worth your time to build. It looks nice. It's really cool. But, it has its limitations. I'm not going to anger the SolidWorks God any more than I have to. I'm going to just take what it gives me here and hopefully roll this model back forward, and we'll see what I can fix and include to get this knit working. Okay, so that knit broke. Most easily accomplished to just delete that and try again. Okay, so obviously the mirror across the side, we need to include our new features in that mirror operation, namely the top. Oh, it's joined, okay. So now that goes across the other side as well. We do have the whole airplane, so as the last operation we can now knit everything we have, which maybe, am I so lucky as we can just, Yeah, gap control. We want to seal all those. I think that would do it. Yeah, so neat. That is a wing blended to a fuselage in fewer minutes than I thought it would really take. There are several different techniques and surface manipulations you can do to make this much more defined if you need to. But overall, I'm pretty happy with how this went. Let's do one more operation. Let's back this whole train up a little bit and show you how you might get a bit more control over this trailing edge. So even before I do the lofts, once I've cut things, I want to go in and use for the first time what you would call a 3D sketch. I'm going to create, which is usually kind of a precarious thing to do in a two-dimensional screen, I'm going to create a spline. Is this the way I like to do it? I think so. Create a spline that goes between those 2 points. And on this side, you can get handles just like you do with anything else. And that handle, I want to select the trailing edge and say collinear. Yes, so this forces in 3 dimensions. Notice there's no sketch plane, we never had to pick one. That forces the trailing edge to come straight off of that. In fact, this other handle, hopefully I can make it tangent to that surface and then we'd really be in a decent shape. Okay, we can, which is fascinating if you really think about the math that was just involved in SOLIDWORKS doing that. Finding a tangent vector at that point in 3D space. Actually, that's working nicely. Okay, so this does give you come back. Does give you control over just some more details of how that. Yeah, we wouldn't want that. More details of how that's blended in. It really allows some fine tuning of that look, and the Loft is probably going to laugh at us and say, "No, I'm not going to do that." But let's see first. Let's give it a chance. So we'll include this as a guide curve now, and you only want one of these curves per sketch. So the yellow edge you see here, just barely in video, is probably the one I'm highlighting, is what the Loft wants to do by default. If we include this element as a guide curve, it now snaps to it and looks like it's of decent shape quality. I'm looking for ripples. I'm looking for high frequency oscillations down here towards the corner. That's where surfacing and lofting really oftentimes just dies. It gets what I theorize is because some of the Fourier series math involved with all this, and just I guess some of the numerics involved, I guess I should generalize, it gets really high frequency ripples and some tight corners on occasion. But here it looks decent. Let's accept that. Let's go down to the next loft that was dependent on the first. And then that one will also, so we've had the, okay, it is, which edge are we using? The front one. Let's include the back edge this time and see it added 3D sketch as a guide curve. Let's see if that works. Good. Oof. It's a pretty tight curve right there. Honestly, if the intent was to improve aerodynamics, I'm not so sure that piece right there is doing it. But we'll leave that to your aerodynamics group and your own hard work. Look at this shape. Something's odd. See how much curvature is happening right at the fuselage body. In fact, let's turn on some other tools to help us see that. Zebra stripes? Yeah, so this is kind of a arbitrary reflection, but it helps you visualize curvature and shapes a bit better to get a look at things. So it really shows not just tangent continuity, but it allows you to see curvature discontinuities as well. So you can see some of the shape is, yeah, wow, what happened? Good grief. That's not tangent at all. Awesome. Okay. Oh. All right, so this first loft is now compliant at the back 3D sketch, but then the influence of that 3D sketch is carried all the way to the front, creating weirdness. Let's see that little oscillation that shouldn't even exist. So I guess if we're going to have one of these 3D sketches, SOLIDWORKS is telling us we really need to do both of them. Okay, so we can do that. Turn off the zebra stripes, go back to the sketch, do a new 3D sketch. Different 3D sketch. You only want to include one of these lines per 3D sketch is my experience. Do a spline from the intersection point of those two, which is here, to the leading edge division here. You see how useful that is to have repeatable divisions. Okay, manipulate the handle. Hold control and click this center line. Make that one collinear. Find the handle for the other end. Click the surface it's attached to while holding down control. Make that one tangent. Make this shape kind of what I want. Good enough for now. Escape, and then now we'll roll the model back forward past those two lofts, adjusting the first loft first. So we will actually use that, so that 3D curve there. So that forces, at that location, the loft to go through that point. It will try to go through that line, I should say, not point, or it will fail. Same thing here in the back. Oh, I think we have maybe some weirdness trying to happen. I don't know exactly what that's going to mean for us, but we'll just click the green check mark and see. Looks okay. Let's see here. Let's adjust the second loft. So we have the edge 3, 3D sketch 2, so 3D sketch 2, and we want it to adhere to this edge that exists. Did it miss? It's really weird, because ideally we should be able to have it attached to both 3D sketches. It should work. Should be an operating word. Let's just accept. See if it's okay. Hey, looks like it's much better behaved. All right, so that's pretty good. Now this is really showing me that this trailing edge bit is too tight here. What I'm going to do is go back all the way up here to where I did after I did the cuts. And where's the first trim? Was this? Yeah, that's the one I'm going to manipulate. Edit the sketch. And instead of the cut going all the way back, let's just drag this point a bit closer, adjust the handles, change the shape, and really these kind of arbitrarily drawn cutouts affect a lot. So don't overlook the shapes you draw here. They matter a bunch. Let's say okay. And then now instead of that, oh gosh, instead of that trailing edge going all the way back, it doesn't, but let's now adjust the tuning of this first three-dimensional sketch, which basically is the tension of that handle. You get a more reasonable blend and not odd swoops. So this now looks quite nice. All right. So now that gives you direct control over the shape, size, and everything of the loft. And guess what? You get to do this for every intersection that you want to, whether it's an antenna to a fuselage, whether it's a wing to a fuselage. Oh, it broke. What? How did that break? Who knows? Well, let's fix it. Yeah, oh, because it's now two elements, not just one. Okay. Yeah. Okay, maybe we don't even need this trim anymore. Let's see what happens when we delete it. Yep, no dependencies. If you see this box open, that means that trim is not used by anything in the future. So you're good to go. Drag this forward. Okay. Last thing we didn't do is include the discrete portions of this blend into the knit. Closing all those gaps, except now we really have a much more sophisticated 3D model of an airplane. This thing would be a chore to mold, but more discussion on that in future videos. For now, if you know these processes, if you've seen what I've done, you go back and review them, you know how to do a blended loft between wings and fuselages in most any CAD program once you adjust for the names and buttons.